All right, welcome to day 2 of Angle Relations, Unit 2. So we're talking about parallel lines and angle relationships today. But first, we're going to do some review on some factoring. So we need something that multiplies to negative 21 and adds to positive 4. So if I look at my factors of negative 21, 7 and 3 come to mind. And then the 4 is going to be positive, which means that the 3 would be negative. So 7 times negative 3 multiplies to negative 21 and adds to 4. So that'll do it. A plus 7 and A minus 3. So now that I reviewed that, go ahead and pause the video, see if you can figure out the next 3, and then come back to see if you are right. So we've got something that multiplies to positive 21 now and adds to positive 10. Since positive and positive, we know they're going to be two positive numbers. 7 and 3 is going to do it again, except now they're both going to be positive. 7 times 3 is 21, and 7 plus 3 is positive 10. Again, now we're looking at negative 15. Factors of negative 15 are 5 and 3. Positive 2, so the smaller number is going to be negative. M plus 5 and M minus 3. Lastly, we've got something that multiplies to negative 12 and adds to 1. Remember, there's a 1 in front of this K. So 6 and 2, well, that's not going to work, but 4 and 3 should do it for us. And since the 1 is positive, the 3 is going to be negative. So K plus 4 and K minus 3. All right, it wants us to draw a pair of same side interior angles. So I'm going to draw two lines. I need a transversal, so it's going to intersect those two lines. And if I want same side, I know it's got to be on the same side of my transversal right here. And again, interior, so it's got to be inside my lines that I've driven here. So same side interior would be this angle and that angle. If I wanted another pair, I could go with, we'll call this angle 1, and angle 2 would be same side interior angles. Again, if I want to look at alternate interiors, or exterior, I'm sorry. So exterior, now we're looking outside of our parallel lines, or not our parallel, just we're looking outside of our lines. So either here, 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 or here. But we're looking for alternate, so we want them on opposite sides of the transversal and on opposite sides of our lines. So if this is one of our angles, then our opposite alternate angle is going to be over here. Again, if we were going to do the other pair, so we would be looking at angle 3 and angle 4 would be alternate exterior angles. All right, let's take a look at our lesson for today. So, learning target, you will be able to use the properties of parallel lines to find the angle measures. So that is your learning target for today. Let's review some parallel lines. Again, if we are looking at parallel lines, we are looking at two lines that are never going to intersect. So line M and line N are said to be parallel. That means they will never cross. They will never intersect, right? The symbol we use is, they literally look like two parallel lines. So we do two dashes like that. And then if we wanted to write this picture, we would say line M is parallel to line N. Another way we'll also do it is if we wanted to label the picture, you'll see like a caret on either side of the parallel line, or sometimes a triangle. So this would also show that they were parallel lines. All right. So why are we talking about parallel lines? Because all of these relationships we are about to discuss will not occur unless lines are parallel. This is very, very important. So none of these relationships we are about to discuss will happen unless lines are parallel. Okay, again, we're going to review some of our relationships. So we can say that alternate interior angles, right? So alternate interior angles are angles that are inside our lines. So if this line AB is one of our lines, right, and line CD is another line, and then we have our transversal, we'll put that in green, right, so this green line right here is our transversal, line EF we would call that, right. So we're looking for two angles that are inside. So if we had inside angles, we're looking at 3, 4, 5, or 6 are possible answers. But again, we want alternate interior angles, which means we don't want them on the same side of the line and we don't want them next to each other. So angle 3 and angle 6 are going to be alternate interior angles. Another pair would be angle 4 and angle 5 would be alternate interior angles, right? And this relationship is, once we say lines AB and lines CD are parallel, we can say that angle 3 and angle 6 are congruent, right? Alternate interior angles are going to be congruent if lines are parallel. And we can say the same thing with angle 4 and angle 5. Congruent angles if lines are parallel, right? So again, if lines are parallel, alternate interior angles are going to be congruent. Transformations. So angle 3 and angle 6 are congruent, and angle 4 and angle 5 are going to be congruent. Again, only when lines are parallel. All right, let's take a look at another relationship. So we've got corresponding angles. Again, corresponding angles, if we look at our two lines and our transversal, corresponding angles are on the same side of our transversal, but one is going to be on the outside and one is going to be on the inside, right? So angle 1, if we're looking for the corresponding angle to angle 1, we would slide down our transversal to get to angle 5, right? We're literally sliding it down and to the right. So this would be a translation, right? So angle 1 and angle 5 would be corresponding angles. And we could also say angle 3 and angle 7 are corresponding angles. And we can do the same thing on the other side, right? So we also have angle 2 and angle 6 and angle 4 and angle 8. So all of these angles are corresponding. Again, if these lines are parallel, so if line AB is parallel to CD, now we can say these angles are also congruent. So corresponding angles are congruent if lines are parallel. All right. All right, let's take a look at the same side interior. So same side interior, again, we're looking on inside our lines. So 3, 4, 5, and 6 are all interior angles, but we want them on this are all of our interior angles. And so if I'm looking for a pair that's on the same side of my transversal, angle 3 and angle 5 are going to be same side interior angles. And same with angle 4 and angle 6. If line AB is parallel to line CD, we can say the relationship between same side interior angles is going to be supplementary, right? And we know from unit 0 that supplementary means two angles that add to 180 degrees, right? So supplementary, the relationship between same side interior angles. So how do I remember this? I say same side sup. Same side sup. And this is because of our relationship with alternate interior angles. So 3 and 6 are alternate interior angles, and we know those are congruent. So I can easily flop out 6 for 3. Well, 5 and 6 are a linear pair, which means they are supplementary. If I take 3 and put it in its place, they're also going to be supplementary. So same side interior angles are going to be supplementary if lines are parallel. All right, let's take a look at some of this now. So we are going to assume lines are parallel. So line L is parallel to line M. That would mean that we can find all of our other angles based on knowing this one piece of information. All right, so let's fill out the easy ones first. 135 degrees is this angle right here. Well, right off the bat, I have a bow tie, a vertical angle. So we know angle 7 is going to be 135 degrees. I can also figure out what angle 5 is because these two guys are going to be linear pairs. So if I do 180 minus 135, that's going to give me my leftover angle, which should be 45 degrees. And again, I have another vertical pair with angle 5 and angle 6, so I know that angle 6 is also 45 degrees. But now I have to shift over. So again, I have a transversal and I have parallel lines. So I have relationships happening with all of my angles now. So angle 5 is going to be congruent to angle 4 due to alternate interior angles. So angle 5 and angle 4 are congruent because they are alternate interior angles. So 45 degrees is number 4 because, again, alternate interior angles are congruent. And we know that that is congruent to number 5, which is also 45. So we have a relationship going on here. We can say the same thing for angle 7 and angle 1 because, again, alternate interior angles. So this guy's 135 and so is angle 7, right? Alternate interior angles. And I could keep moving through those relationships, right? So angle 5 and angle 2 are corresponding angles. So angle 2 is going to be 45 degrees. And angle 3 is corresponding with angle 7, so that's going to be 135. And lastly, angle 6, which we figured out earlier was vertical, so that is 45 degrees over here, right? So we have all of these relationships that we can use. And once we figure out one angle, and we know we have parallel lines, we can figure out the rest. But again, parallel lines is important. All right, why don't you pause the video and see if you can figure out this one, and then come back and see how you did. So, given 35 degrees for angle 2. Parallel lines, this is very important. I need that in order to figure out some of my relationships. So once I know that these lines are parallel, I can easily fill in the rest. 2 and 3 are both going to be 35 because we have bow tie, right? Vertical angles. Angle 1, I've got linear pair with angle 1 and angle 2. So I can find the other angle by subtracting. So now, again, 145. Angle 4, 145 for those vertical angles. Now I need to start shifting down to line L. 2, sub 2, right? Well, I'm going to use, let's use alternate exterior angles now. So angle 2 and angle 7 are going to be alternate exterior angles, so they are going to be congruent. And angle 1 and angle 8 are alternate exterior angles, so those are also going to be congruent. And then I can fill in the other two based on vertical angles. So angles 5 and 8 are congruent, and angles 7 and 6 are congruent. So again, once you figure out one, it's pretty easy to figure out the rest once you know the relationships. All right, let's throw some algebra in the mix because it's just too easy to throw some numbers out there. So again, we're assuming parallel lines. So first thing we need to do is establish how we're going to solve this problem, right? I'm looking at this guy right over here, and I'm looking at this angle over here. Now, this angle and that angle currently have no relationship. Those are not related in any which way. there's multiple ways I can attack this problem. One of the ways I can do it is to figure out what angle 8 is, because this angle and angle 8 are corresponding, which means they're going to be congruent. So that's the route I'm going to take. If I figure out what angle 8 is, which is 180 degrees minus 45, because again, these are linear pairs, so 180 minus 45 would give me 135 degrees, right? So that means that angle 8 is 135 degrees. Well, so is 5x plus 35, because these are corresponding, right? So the relationship I used here was linear pair. And now I'm going to go ahead and set up my algebra problem based on the fact that I have corresponding angles. Congruent. So I'm going to say 5x plus 35 is equal to 135 degrees. Now I just have to solve, so I'll subtract 35 from both sides, giving me 5x is equal to 100. I can divide by 5, and so x is equal to 20, right? Again, one way of getting there. You could also make angle 3 equal to 45, because those are corresponding angles. And you could then set angle 3, which is going to be 45 degrees, plus 5x plus 35 equal to 180, because those are a linear pair. So multiple ways of solving that one. All right, let's take a look at a couple more. So we want to find the value of x and y. So let's look at the x values first. Here's my x equation and my x equation over here. So the first thing you must ask yourself is, what is the relationship between those two? Here are my lines, and they are parallel. I see the symbol here, and it also says assume parallel lines. So parallel lines, I have my transversal. So if I look at my relationship here, I've got two angles that are outside of the parallel lines, opposite sides of my transversal. So first off, I have alternate exterior angles, which means congruent. So I'm going to set 2x plus 5 equal to 17x minus 70, because again, alternate exterior angles are congruent. And now I can balance my equation. I'm going to add 70 to this side and add 70 to that side, giving me 2x plus 75 is equal to 17x. I'm going to subtract 2x from both sides, giving me 75 is equal to 15x. And then lastly, we divide by 15, giving me x is equal to 5. So I've solved for x, and now I have to solve for y. So again, I'm going to look at my y equations. So I've got this angle and this angle, which are both inside my parallel lines. So I'm looking at interior angles, but now they're both on the same side of the transversal. So these are same side interior, which means same side sup. So 3y plus 5 plus 5y plus 15 is equal to 180 degrees. Combine like terms, 3y plus 5y is 8y, 5 plus 15 is 20, equals 180 degrees. I'm going to subtract 20 from both sides of my equation, giving me 8y is equal to 160, and then I'm going to divide by 8, giving me y is equal to 20. Oops, sorry about that. So x equals 5, y equals 20. I stated my relationship, I set up my equation, I showed my work, and I solved my answer. Let's take a look at yet another one. So see if you can try and figure out at least how to set this one up. Tell me what the relationship is, and then go ahead and figure it out. My big hint to you is you have to factor. All right, hopefully you're checking back to see how you did. I've got one angle here. I've got another angle outside. I have parallel lines. These two little guys right here are telling me parallel lines. So I can use my relationships. Exterior angles. They're both on the outside of my parallel lines, but they're on opposite sides, so they are alternate exterior angles, which means congruent. So set them equal. A squared equals 10a minus 24. Well, I've got an icky quadratic here, so I've got to get it all on one side and set it equal to 0. So I'm going to subtract 10a, and I'm going to add 24 to get rid of that on both sides. So I get minus 10a plus 24 equals 0. And again, my hint was that we have to factor, so factors of 24, well, I see 6 and 4, and this is a positive, but these are both, this is a negative, so that means these are both going to be negative. So I've got a minus 6 and a minus 4 equals 0. Again, I got to keep moving, so I'm going to set that one equal to 0, and I'm going to set this one equal to 0. So my solutions are a equals 6 and a equals 4. All right, well, if I plug it back into a squared, I get 36 and I get 16. So that one works for both equations. If I plug a into this equation, I would get 10 times 6 minus 24. So I'm going to get 36, so that'll work, right? And if I plug in 4, I'd get 10 times 4, which is 40, minus 24, which is 16. So both of these solutions are going to work, and that is okay. Sometimes we have more than one solution. All right, let's look at one last example. So we first need to determine what our relationship is. I've got an angle here, and I've got an angle here. And these guys are next to each other and they form a line, so I have a linear pair, which means they are going to be supplementary. Add to 180, right? Sup. So I'm going to set these equal to 180. X squared plus 4x plus 109 plus 50 equals 180. Again, I've got a quadratic, so I know I have to make this equal to 0. So x squared plus 4x, there's nothing to combine there. I have 109 and 50, so 159 equals 180. I'm going to subtract 180 from both sides of my equation, giving me x squared plus 4x minus 21 equals 0. Again, I have to factor what multiplies to negative 21 and adds to positive 4. 7 and 3 will work, but 3 is going to be negative. So I would get x plus 7 and x minus 3 equals 0. My solutions then are going to be x equals negative 7 or positive 3. If I plug in negative 7, that solution will work. If I plug in positive 3, that solution will work. So both of my answers will work in my equation. All right, so hopefully you don't have any questions. If you do, please pop in and see us, and we will meet next time.